Graphing functions. You've done a little bit of this already, but we're going to expand on it a tad. I think you've got a good base for it, so it should make this lesson pretty quick and painless for you. The directions on the can of paint describe the function. And here were the directions that were on that can of paint. 1 gallon covers 400 square feet of a sealed, non-textured surface. We're going to create a function table relating quantity of paint in gallons, G, to area, A, covered in square feet. So, and then we're going to use numbers from the table to graph the function. First of all, let's make our table. We got gallons and we got area. Bang. Okay. So now I'm going to pick some values to go into this function. If I use 0 gallons, I'm not going to cover any area. If I use 1 gallon, I will cover 400 square feet. If I use 2 gallons, I will cover 800 square feet. I think we see the pattern there. Let's use some fractions because I know you guys love them so much. If I use a half a gallon, that would cover 200 square feet. And if I use a quarter of a gallon, that'll cover 100 square feet. Okay. Now let's graph this. So the first thing we got to do is make a coordinate plane here. And the bottom is going to be gallons of paint. Okay. 1, 2, 3, 4. 1, 2, 3, 2. 1, 2, 3, 3. So I'm just, since I got some fractions here, I'm going to show everything. Okay. All right. Along the left-hand side, this is going to be area in square feet. I'm going to go by hundreds. 2, 3, 4, 5. That would be 1,000. So that is area in square feet. And then we'll plot these points. 0, 0, 1, 400. I'm sorry, that's 1 quarter and 100, 1 half and 200, 1 400, 2 800. Okay, and then we'll draw a nice straight line right through the middle of them. It's supposed to be a straight line anyway, since I'm doing it without a ruler. And I also made my graph without graph paper. It makes these dots look a little crooked, but they're actually all in a nice straight line. So there we go. We've graphed it. Let's move on. Referring to problem A, which equation below shows the relationship between the number of gallons, G of paint, and the area covered in square feet? What do you guys think? Which one of these appropriately shows the relationship? Is the area that the paint covers 400 plus the number of gallons? Is it 400 times the number of gallons? Is it 400 divided by the number of gallons? Is the area the number of gallons divided by 400? It's 400 times the number of gallons. Okay, 1 gallon covers 400. 2 times 400 is 800 because 2 gallons covers 800. 3 times 400 is 1,200 because 3 gallons covers 1,200 square feet. Again, referring to problem A, painting 700 square feet of wall would require about how many quarts of paint? Wouldn't it be great if every time, there's kind of some trick questioning, it would show up in italicized words like quarts is right here? You got to remember the graph we made is based on gallons. Okay, but let's say that 700 square feet, let's call that about 800 square feet. I know it's a little bit off. And 800 square feet is 2 gallons. Well, there's 4 quarts in a gallon. So that would mean we'd need about 8 quarts. Really, I don't know. I mean, there's a better way to look at this. Since there's 4 quarts in a gallon, doesn't every quart cover 100 square feet? So really, we could say it's exactly 7 quarts. One quart covers 100 square feet. So 7 quarts covers 700 square feet. Add that in there. That's probably a better way to look at it. Estimation is nice though too. You got to buy 8 quarts if they sell them in quart, and then you'll have a little bit left over. Janine works in a high-rise building. When she wants to go to upper floors, she enters an elevator and pushes a button. That's an input. And the elevator takes her a distance above street level. That's an output. Assuming that the building has 12 floors and that floors are 10 feet apart, graph the relationship between the floor Janine is on and her distance elevation above street level. Let the tick marks on the vertical axis increase by tens. Okay, so let's start off here by making a table of values. We got our inputs, which is the floor that she's on, and then we've got our outputs, which are the heights that we're at. Okay, so that's what our table is going to look like. All right, so our inputs are our floors. Okay, so the first floor we can be on is the first floor. And if we're on the first floor, we're 0 feet above the ground. If we're on the second floor, we're going to be up 10 feet. Third floor, we'll be up another 10 feet, 20 feet. Fourth floor, we'll be up another 10 feet, that's 30 feet. And there we go. Got a pattern there. All right, now let's use that information, here it is over here, to graph this function. All right, so vertical and horizontal axis there. We got our floors, our input. We got our heights in feet. That's our output. It's a 12-floor building, so I'll take my inputs out to 12 here. And the maximum height is going to be 110 feet, I think. So I'll plot by tens over here. And then we'll plot all these points. Okay. Floor 1, 0 feet. So it's right on this x-axis. Floor 2 is at 10 feet. Floor 3 is at 20 feet. Floor 4 is at 30 feet. Floor 5 is at 40 feet. Floor 6 is at 50 feet. 7 is at 60 feet. 8 is at 70 feet. 9 is at 80 feet. 10 is at 90 feet. 11 is at 100 feet. And 12 is at 110 feet. It's a lot easier with grid paper, but I'm just showing that it can be done without it. And there we go. We've graphed it all. So in problem D, what is the domain of the function? The domain is your inputs. The domain is the inputs, which is our floor numbers. So what are the possible floor numbers? It's only a 12-story building. So the domain is, put it in set notation, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Another way you could write that, you could just say the domain is the integers from 1 to 9 to 12. Okay? Is the relationship described in problem D proportional? I'm telling you it is not proportional. They're in a straight line, which is these points are anyway, which is one of the requirements of being proportional. But if we drew a line through them, that line would not go through the origin. Okay, in other words, we've got some ratios here that do not equal each other. I'll explain this in just a second. Okay, when we're on floor 1, we're 0 feet above ground. When we're on floor 2, we're 10 feet above ground level. And when we're on floor 3, we're 20 feet above ground level. These ratios don't equal each other. That's why this is not a proportional relationship. Okay, that's all I've got for you tonight. Have a great night.